Welcome to another video. So today we have an exponential equation given that x raised to x is equals to 8. So we are told to find the value of x such that when I substitute here and here, the output should be 8. Actually, let us start maybe by inspection. If it is very easy to predict the value of x, let's say for x is equals to 1, then this is going to be 1 raised to power 1. Of course, that is 1. So when x is equals to 2, so I'm going to get 2 raised to power 2, that is 4. Okay, let's go to x maybe is equals to 3. I'm going to get 3 to power 3. Of course, that is 27. It is very big, more than 8. So that means x ranges from 2 to 3 from this inspection. So I'm going to take you through step by step. So if you're watching us for the first time, like this video, subscribe. Remember to watch up to the end because I have an alternative approach where we're going to find the actual value of x. So on the solution part, if I have x raised to power x is equals to 8, then the first approach, I'm going to introduce the ln on both sides, or the natural log, so that this now changes to x to the ln of x is now equals to ln of 8. Nice. Next step, you need to recall that this x can be rewritten as exponent to the ln of x, because x is equals to this. When you take the exponent of a natural log, so meaning I'm going to rewrite this x as this, so that I have exponent to the ln of x multiplied by the ln of x should now be equals to ln of 8. Next step, I'm going to start by writing this so that I have ln of x multiplied by the exponent to the ln of x is equals to ln of 8. So at this particular point is where I'm going to introduce the Lambert W function, which says that when I have the w of a to the exponent of a, then that automatically gives me the answer as a, so that if I introduce on both sides, then I'm going to have the w of ln of x multiplied by the exponent of ln of x should be equals to the w of ln of 8. So it is now very easy to see that this represents a and that one also represents a, meaning on my left hand side I'm going to end up with a ln of x is now equals to the w of ln of 8. So next step, I'm going to introduce the exponent on both sides. I'm going to introduce the e to the both side of the equation so that I remove the ln of x, because so I'm going to have exponent to the ln of x is now equals to the exponent of w to the ln of x. But recall from this particular point, we said that x to the is equals to exponent to the ln of x. So meaning at this other end, this now gonna change to x is equals to e to the w of ln of 8, like that. So that at this particular point, I'm going to have x is equals to the exponent of the w of ln of 8. And using my scientific calculator, I'm going to compute this and get, when you take the w of ln of 8, of course, I'm going to end up with e to the w of ln of 8 from my calculator is giving me 0.87063351838. Of course, it is an irregular pattern. So that means for me to get x, I'm going to take the e to the whole of this. Again, punching my scientific calculator, I'm going to get x is equals to 2.38842348451. It's also an irregular number with a known pattern, but I can take approximately x now equals to the up to 4 significant figures. I'm going to get 2.388 as the exact value or approximated value, which when I substitute in, let us verify, when I substitute in x raised to power x, should of course give me the output as 8. So taking x, the whole of this, I'm going to get, if you punch 2.388, of course raised to 2.388, you're getting an approximated value of, using this, I'm going to get 7.999366 533533. Also a particular number that you don't know the actual pattern of it, but you can take from here up to this. The output now becomes 7.993 or 994 up to 4 significant figures, which can be approximated as 8.0 up to 1 decimal place. So of course, we are now confident that the value of x which satisfies our exponential equation is actually 2.388, which we initially predicted using by inspection approach that the value of x will range between 2 to 3. And of course, it is indeed true that our x is 2.3888. So thank you for watching up to the end. Kindly subscribe to this channel, comment, turn your notification on, and then you can share again. So let's meet in the next video. Then goodbye for now.